I'm excited about our program or presentation tonight. I'm just going to turn it over to Jim, and we're going to be looking at small vessels that are, what would you call it, multi-section?
They're called transitional
vessels. But Jim, take it away.
We had trouble with the audio recording, so I'm going to attempt a voiceover. I was asked to do a demo for the Alamo Woodturners pin special interest group. I don't make a lot of pins, so I decided to do a demo on transitional vessels. I attended the recent Segmented Woodturners conference in Chicago. This is where I learned about Jim Rogers' transitional vessels. I was impressed with Jim's creations that I saw in the instant gallery and in one of the meeting rooms. We had a question. Is this vessel made from 4 pieces of wood? Actually, this vessel was made from 3 pieces of wood. 2 segmented rings, each with 12 segments, and several layers of thin veneer. The thin piece of wood at the bottom was probably part of a sacrificial block. When I got back from the conference, I made this small lidded box. The lower body is mesquite, the upper body is walnut, and I used an oak cap for the lid. This is my first attempt at making a Jim Rogers style transitional vessel. The upper and lower bodies are walnut. I discovered that Jim Rogers wrote an article about transitional vessels for the AAW in 2008. In this case, the vessels were much larger than these small ones that we're going to be talking about today. Here's a close-up of my first transitional vessel. I'm trying to show the 3 layers of veneer that surround the feature ring. Whenever I do a segmented project, I always begin by designing the feature ring. I use a software program called Woodturner Pro. This gives me the outer diameter, the inner diameter, the segment edge length, and the width of the spacers. This is an unassembled ring with walnut, maple, and some blue veneer pieces. The first step in making the feature ring is to cut the wedges. Here I'm using a Pete Mackin sled. The component on the left establishes the length of the wedgie, and the component on the right establishes the angle of the wedgie. I use a pencil to push the wedges out of the way so I don't cut my fingers. And I'm going to make 12 wedges, but I usually make 2 extra just in case one of them doesn't come out. And as you can see, I get a little faster as I get more confident. Cutting the spacers is easy. I have an aluminum stop block that establishes the length of the piece, and I just cut them off and push them out of the way with a pencil. I cut 14 spacers. I cut the veneer with a paper cutter. This paper cutter is over 100 years old. It was my wife's grandfather's creation. By the way, Jim Rogers recommended not cutting the veneer with scissors. I'm making 26 veneer pieces since I'm going to put a veneer piece on either side of the maple spacers, and I want a few extra in case something doesn't work out. Now it's time to assemble the ring. I use Type Bond 3 glue because it gives me more working time. In this case, I need to butter 48 sides of wedges and spacers. So I get some help from my wife to make the process a little bit easier. I apply the glue with a craft brush, and Debbie inserts the spacers. I use several rubber bands to hold the pieces together. I flatten the rings on a disc sander. I don't use my drum sander because the diameter of these rings is too small. I built the ring out of 3/4 inch stock. That makes a ring that's bigger than I'll need in my transitional vessels. So here I'm using a product called AccuSlice to split the ring in half, which gives me 2 rings for the effort of making one, and it's an appropriate size for the transitional vessels. I like to build the transitional vessels in stages. In stage 1, I mount a sacrificial block on a faceplate and then glue the lower body with intervening layers of 1 or more pieces of veneer. In this case, I used mahogany as the sacrificial block and mesquite for the lower body. The next step is to establish the approximate wall thickness of the lower section. I use a parting tool to cut a shallow groove at the established wall thickness. And finally, I use a bowl gouge to cut a shallow recess in the center of the lower body. This completes stage 1. Stage 2 involves gluing 3 layers of veneer and the lower segmented ring to the lower body. This I did at home to save time. Notice the segmented ring is wider than the wall thickness, so I'm going to cut out the center part of the ring. The part that is removed will be used for the top ring in the vessel. Thanks to Jim Rogers for this idea. I used a parting tool to cut a groove at about the inner wall thickness of the lower body, cut all the way through the segmented ring. think you can see the purpose of the recess I cut in the lower body. The inner portion of the ring is not glued and can easily be removed. Oh, I forgot to show the video on how to glue the veneer layers. Let's do that now. To separate the lower body and the lower segmented ring with 3 layers of veneer. In this case, blue dyed maple veneer and plain maple veneer. I use Type Blond 2 glue, spread it out with my finger, and then stack the 3 pieces. Centering the segmented ring proved to be more difficult than I expected. In this case, I used the metal cone that came with the one-way revolving center, and this worked pretty well. I found a better way to center and glue the rings. Cut a lip in a jam chuck that fits the inside of the ring. Leave a shoulder for clamping pressure. Cutting out the center part of the segmented ring is so much fun. Let's watch the video that I made earlier. The last step in stage 2 is to trim off the veneer. Use a sharp tool to avoid tearing out the fibers in the veneer layers that might leave gaps. I'm using a detail bowl gouge for this. Now I'm going to use a bowl gouge to do shaping of the assembly of the lower body and the feature ring. support is a good idea anytime you can use it. Now we have a general shape for the outside of the lower body. An optional step at this point is to drill out the lower body section with a Forstner bit. Drilling out the lower body just makes the hollowing that we'll do on the fully assembled vessel a little bit easier. I used a homemade depth gauge to verify the depth of the hole that I made. That looks about right. I repeated the drilling process with a larger drill bit to open the lower body up just a little bit more. Next, I used a Hunter tapered tool with the number 1 cutter to further open up the lower body following the outside shape. The Hunter tool cuts best when presented at a 7 o'clock angle. I'm using a Thompson handle which has flat sides. If I put my thumb on the engraved part, I know the cutter is properly aligned. I talked to the folks at the Hunter booth at SWAT last year, and they recommended rotating the cutter every time you use the tool to keep it sharp. With the Hunter tool, it didn't take long to hollow out the inside. The result was nice and smooth. It won't require a lot of sanding. Moving on to stage 3. When making this assembly, I managed to break the lower body off the sacrificial block. So I cut a tenon on the lower body and mounted the assembly in an easy wood chuck. At this point, I'm working on a complete assembly. I will trim off the excess veneer and shape the upper body. Don't forget to use tailstock support anytime you can.
You're hitting.
Yeah, no problem. Okay.
Not for long.
I'm turning it at about 1,000 RPM.
Okay.
Now I need to shape the upper body, working on the transition from the lower ring to the upper body and the upper ring. Like I did for the lower body, I'm going to use a Forstner bit to drill an opening in the upper body. I only have to drill through the veneer layers and the short portion of the upper body. Using a slightly larger Forstner bit, I'm drilling out the upper segmented ring and the upper body. I did this because the segmented ring was not exactly round. Now we'll do a little bit of hollowing on the upper body and ferret into the previous hollow-in that we did on the lower section. Wish it was this easy to put it back together. Well, I'll be making it tenon. The trouble with paper joints is that they are designed to break off easy. I used too much lateral force and this caused the joint to fail. I have made 12 of these transition vessels, and now I use a one-way bowl steady rest to provide support during the hollowing process. Here's a few pictures of the transition vessels that I've made. Well, that's all. Thanks for watching.